10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello everyone, this is Professor Vincent Torre Bongolan and welcome to the second part of the video lecture presentation about descriptive statistics. Alright, so during the first part of the video,
namumula ka na.
hello everyone, so I am here now at my condominium unit in Cubao, and I would like to do a quick demo of the Internet of Things and the AI application that is developed for my condominium unit. What is Digital Week?
The Digital Week 2019 is an ADB annual.
Hello everyone, this is Professor Vincent Torre Bongolan and welcome to the second part of the video lecture presentation about descriptive statistics. Alright, so during the first part of the video, we already discussed how to construct, how to calculate, and how to describe data for ungrouped data. Alright, so we already used the ungrouped distribution of the data. Alright, so before that, we need to define again what is all about descriptive statistics. Descriptive statistics is a scientific and systematic process of summarizing and describing the characteristics and the behavior of the data. Descriptive statistics is very useful by providing basic information about the variables in a given data set, and is very useful by highlighting the characteristics and the behavior of the data set. Alright, so as I mentioned also in the first part, there are two methods of describing data. Alright, so these are the measure of central tendency and the measure of the variability. Alright, so the measure of central tendency is also referred to as a measure of central location or simply location. It is useful by providing the exact location of a certain data point in a data set. Measure of central tendency attempts to identify the location of a single data in a given data set. Now, these are the most commonly used measure of central tendency. These are the mean, median, and mode. Alright. And the easiest way, before we proceed, the easiest way and the most organized procedure before calculating the measure of central tendency for grouped data is to construct a frequency distribution. Alright, so before doing this for group data, all you need to do is to convert first the ungrouped data to a group data, and that is through a frequency distribution table. Okay, so to do that, you need to go to the description of this video so that you can be able to redirect on how to construct a frequency distribution table. Alright, so after which, this is the formula for getting the average or the mean for grouped data. Alright, X bar is equal to the product of the frequency and the midpoint over the total number of frequency. Alright, so technically, to perform the calculation, construct the preliminary components, of a frequency distribution table to organize the data showing the frequency and the class midpoints. Okay, so class midpoint is also called class mark, and this was denoted by symbol X or M. Okay, so do not be confused when you see a frequency distribution table and you see the value of X, that is the midpoint. Or if you see the letter M, that is also a midpoint. Okay, so it depends upon the analyst. It depends upon the lecturer. So in my case, I used to use the X over M. Alright, so this is the formula for the median. Like I said, median is the middlemost part in a distribution of a given data set. This definition is good and the same for group and ungroup data. Alright, so the formula is median is equal to the lower boundary. Okay, lower boundary of the median class. Okay, and the CFB is the cumulative frequency before the location of the median class, and F is the frequency. Okay, so this is important. The first step to locate, or identify or determine the location of the median class is you need to go through the cumulative frequency. Okay, you need to construct a cumulative frequency first. And this is the mode. Okay, so LMC is the lower boundary of the class, okay, or the model class. V1 is the frequency of the model class minus the frequency before the model class. And D2 is the frequency of the model class minus the frequency after the model class. Alright. Model class is the class interval with the highest frequency. Okay, so remember the definition of the mode is the value that occurs most frequently. So the same with group data. A model class is located in the class interval with the highest number of frequency. Alright. This is the data that we're going to use. Okay, so this is a snapshot of the frequency distribution table. This is not actually a snapshot, but this is the actual frequency distribution table. Okay, so this is the converted distribution of the ungrouped data to a grouped data. Okay, so please go to the description of this video to know how to construct a frequency distribution table. Alright, so let's calculate the mean or the average. Okay, so first thing to do is to calculate the class midpoint. Okay, class midpoint is symbolized by the letter X or letter M. Okay, to do that or to calculate the class midpoint, all you need to do is to add the class interval. Okay, add the lower limit plus the upper limit, divide by 2. Okay, so 039 plus 213 divide by 2, you will get 126. 214 plus 388 divide by 2, you will get 301. 389 plus 563 divide by 2, you will get 476, and so on and so forth. Alright, so you need to sum 126 plus 301, 476, 651, 826, and you will get 2,380. Okay, so to calculate the average for the grouped data, all you need to do is divide the two. Okay, 2,380 divided by 192, you will get 12.39. So that is the average. Alright. Now let's proceed with the median. Okay, so remember, median is the middlemost part of the distribution. Okay, don't forget that definition because the definition is the same for ungrouped and the grouped data. And the same procedure, all you need to do is to arrange the data from the highest to lowest. So in this case, we arrange the data from the lowest class interval to the highest class interval. So the data begins from 039 to 213, 214 to 388, 389 to 563, 564 to 738, 739 to 913. So it was a range from lowest to highest value. All right. First step to do is to locate or to determine the location of the median class. Okay, so how to locate the median class? Okay, so remember the frequency is 192. Divide by 2, you will get 96. Okay, so go to the cumulative frequency. Do you think the cumulative frequency under the class interval 039 to 213, 96 is being covered? Definitely no. But in the cumulative frequency for the class interval 214 to 388 is 98. So the computed location of the median class is 96. So this is lower than 98, right? So meaning to say, the median class is at the class interval of 214 to 388. So that is the median class. Okay. So to get the LM, that is actually the class boundaries of the class interval. Okay, where the model class is located. Okay, so the model class again is 214 to 388. So we need to get the class boundaries. So in the construction of, in constructing the frequency distribution table, to get the class boundary, we have to subtract 0.5 from the lowest class interval, and we have to add 0.5 from the upper class interval. Okay, so the lower class interval of the model class is 214. So 214 minus 0.5, that would be 213.5. So that is the LM, 213.5. Okay, so 192 divided by 2 minus 43. Okay, but why 43? Because that is the cumulative frequency before the model class. Okay, again, 43 is the cumulative frequency before the model class. Okay, so the model class again is 214 to 388, and the cumulative frequency of the model class is 98. So what is the cumulative frequency before 98? That is 43. All right, and the frequency of the model class is 55. Okay, go to the column 2 for the frequency. Again, so the model class is 214 minus 388, and its frequency is 55. And 174 is the interval, okay, or the class width. So how do I get the 174? 213 minus 39, that's 174. 388 minus 214, that's 174. 563 minus 389, that's 174. 738 minus 564, that's 174. And 913 minus 739, that's 174. That is the class width. Alright? That is the class width of the class interval. Okay, applying the value, 213.5 plus the 96 minus 43 over 55. Okay, so you need to do first is 96 minus 43, and then multiply it by 174, divide by 55. Okay, so again, 96 minus 43, multiply by 174, divide by 55, plus 213.5. So we applied the PEMDAS rule. Okay, so 213.5 plus 0.963636 times 174, we will be getting the 381.17. So meaning to say, the median is 381.17. So this is the actual median of the grouped data. As you can see, the median class is 214 to 388. So the actual median was still belong to the model class. So meaning to say, the median for the group data is located under the median class of 214 to 388. And the actual median for the group data is 381.17. Alright, so let's proceed with the mode. Okay, so the same procedure. We need to identify the lower class boundaries of the model class. Okay, so again, the first step to do is to locate or to determine the location of the model class. Okay, so remember the definition of mode. This is the value that occurs most frequently. Based on the table, the frequency for 214 to 388 is 55, meaning to say most of the values are within that particular class interval, 214 to 388. So that is the modal class. Okay, so calculate the class boundaries of the lower class interval. So again, 214 minus 0.5, that would be 213.5. So that's why we will be having a value of 213.5 to replace the LMC. Okay, so D1 and D1 plus D2. Okay, so to get the value for D1, subtract the frequency of the model class before the frequency of the model class. Okay, so what's the model class again? 214 to 388, and the frequency of the model class is 55. Okay, so to calculate D1, 55 minus 43. Okay, that's the frequency before the model class. So 55 minus 43, that would be 12. So that is the value for D1. And the value for D2 is that 55 minus 36. That's the frequency after the model class. Okay, so 55 minus 36 is 19. So applying the formula, 213.5 plus 12 over 12 plus 19 equals 174. Okay, so 12 times 174, we will be getting 2088 divided by 31. We will be getting the value and then add it to 213.5. So the mode of the distribution is 280.9, or simply 281. Okay, so again, the mode is still located in the class interval where the model class is located. Alright, so I hope everyone was clear how to construct a frequency distribution table to calculate the measure of central tendency for the grouped data. Thank you.